Hi everyone, I'm back again in avatar form. By appointment, I can't make it with you, but please, I hope this short lesson will still do you good because the turnaround time for chapter 8 is very quick. So after today, tomorrow's 8.3, we have a review, and bam, we're done chapter 8. And so there's going to be a test. The test is not long, obviously, because there's 3 sections to it, but the content of which you can see us as teachers trying to be a little bit tricky about it because there's so little content to cover. We can go a little bit more in depth. Now, what's nice about today's lesson, and I hope you're going to keep up, is that it's a reiteration of a relationship I've been trying to hammer home last week, right? The idea that pyramids and cubes, so a square base pyramid and a square base prism, there is a strict relationship between. If I had this block of wood and I shaved it down into a pyramid shape, what would be the relationship quantity wise? How much of this is left versus how much of the wood is left here? And I think you see where I'm going with this. With that same idea, we'll apply it here. Like if I had a cone versus a cylinder, the dimensions of the cone and the cylinder are very similar. If I had this cylinder and I shaved and shaved and shaved off the wood until I made a perfect cone, what would be the quantity or number relationship between these two? And I think you see where I'm going with it. The reason why we're taking this time to hammer that home is because I can ask you questions about a cube and take for granted that you know how to answer questions about a square base pyramid with the same dimensions, right? Because there is clearly a direct relationship between the two. I am taking your understanding of that for granted. I'm going to assume you know. Same thing with pyramids. If I give you information and describe a cylinder, you automatically know certain properties of the cone that corresponds to the dimensions of that cylinder as well. Okay, so that's how I can be a little bit more tricky. So let's explore this just a little bit. So again, we're going to go through this and compare these two shapes. We'll compare these two shapes. We'll practice some word questions, and then we're good. All right. Any questions you have, please hold it until tomorrow. Or if you have a burning question you need answered, send me an email. Here we go. Volume is a measure of how much space a three-dimensional object can occupy in this universe, right? Literally, just how much how much space does it take up? It is measured in cubic units, so that could be centimeters cubed, meters cubed, kilometers cubed, millimeters cubed, you name it. And as a fun fact, cubic units can also be directly translated to milliliters. If you have milliliters, liters, kiloliters, all that stuff, liters, a measure of water or liquid, we call that volume. And so milliliters doesn't need a cube because it's automatically assumed you're dealing with a 3D shape. Fun fact, okay? You'll never see milliliters cubed, ever. Here we go. Let's compare the volume of a square base pyramid to that of a square base prism. So I want you to see a couple of things. Numerically, let's compare. I have one side of the base as 4. I have one side of this base as 4. And because this is a square base, what the other side of this base is 4. And same here, the other side of this base is 4. The height from the middle of the square to the tip of the pyramid is 7. The height of this square base pyramid from the corner, bottom corner, to the top corner is 7. So in terms of dimensions, they're very similar. If not, they're identical in terms of side, and height. But obviously, the shape of it is different. But because the dimensions are the same, I think you can argue there's going to be some kind of numerical relationship between the two. So how do you think the volumes of the two objects above will compare? Let's pretend we didn't know what the formula was. What could you say? Again, I'm not looking for actual numbers. I'm looking for a way you could describe something. So here it is. So how do you think volumes of the two objects above will compare? The volume of the pyramid will be some fraction of the cube. or of the prism. Why? Well, this is because both, I guess, 3D shapes have identical dimensions. I'm going to put that dimensions in quotes. Okay, so there must be some relationship in terms of length, width, and height. They're exactly the same. There's got to be some kind of connection between the two. So we're going to take this, we're going to calculate based on these things, and you'll start to see how the numbers are exactly the same, except for the division of 3. For the volume of a pyramid, it is one side, the base, times the other base, times the height, divided by a 3. The volume of the prism is going to be length times width times height. So here the base, one side is the base is 4 times a 4. The height from the middle of the square to the tip is 7, and divided by 3. For the prism, the length is a 4, the width is a 4, the height is a 4. So again, there is that relationship. The 4 and the 4 and the 7 do show up identically in both volumes. The only difference is this fraction. It will be some the volume of the pyramid will be some proportion of the prism. Right. So let me finish this off. 4 times 4 times a 7. 112. And I might be running out of space. So this is 112. This is in centimeters, correct? Oops. Yes. So this is centimeters cubed. And 4 times 4 times 7 divided by 3 is approximately 37.3 repeating centimeters cubed. Okay, so conclusion. Well, all I'll say is the volume of a pyramid is 1/3 the volume of a prism. The exact formula for volume of a prism appears in the volume of a pyramid, right? That highlighted green part. So these answers are essentially going to be repeated for the cone and cylinder. If you are still in the midst of copying this down, don't worry about these wordings. You can always visit the video again or ask the substitute to stop at some point so that you can copy, or go back to this video so you can copy. I'm more impatient to do the same relationship for our cylinders and cones, so let's get to it. How do you think the volumes of the two objects will compare? Well, same as before. If I have a height of 7 on the side length, then this dotted line from the center of the circle to the center of the circle should also be 7. Just like that. So let's pretend this was a block of wood, and I shave it down. And I shave it down. I get the exact same shape. Right? So there must be, once again, some relationship. I'm literally not going to rewrite it. I'm going to copy it. Hypothesis. How do you think the volumes of the two objects above will compare? Well, literally, the volume of the cone will be some fraction of the cylinder because they have the same dimensions. Calculate the volume of each object. Once again, okay, the volume of a cone is going to be pi r squared height divided by a 3, whereas the volume of a cylinder is going to be pi r squared, so the area of the face, times the height. And I hope even while I'm doing this that you're not looking at the equation, but rather you do recognize, again, it's the area of the face times the height every single time. Area of the face times the height for prisms. So pi r squared height divided by 3 pi r squared height. So just like that, once again, this, as long as the dimensions are the same, this setup, the volume of the cylinder, shows up inside the formula for the volume of the cone, and just dividing by 3 every single time. So for a cylinder, if this is, let's use 3.14 as pi, the volume is approximately 351.7 centimeters cubed. That same number is here, but divided by a 3. So this is approximately 117.2. Once again, approximately. Okay. So once again, I'm not even going to retype it. What is the conclusion that I've come to? The volume of a cone is 1/3 the volume of a cylinder. The exact formula for volume of a cylinder appears in the volume of a cone. Again, the wording is there. It's long. I don't want you to waste time copying it right now. I want you to grasp the concept that there is directly a relationship, and that relationship is a quantity factor of 1/3. So let's try some word questions in an attempt to try and make things tricky. A cube, very important. A cube has a base length of 16. That reveals a lot. I have a cube of equal distance. If the base length is 16, then that means this is 16, that's 16, and that is 16. Determine the volume of a cube. Well, the volume of a cube, I know you memorize it as s cubed, s times s times s, but again, I'm going to force you to think about it as the area of the face times how long it is. Okay, or if I'm dealing with a 3D shape like this, the area of the face, the floor, times how high it is. So here we go. The area of the face is 16 times 16 multiplied by how high it is. That would be 16 cubed is exactly 4,096 centimeters cubed. Determine the volume of a pyramid with the same base and height. That's another way of saying I take this cube and, let's see, using red, I take this cube and I created a pyramid with it. If that is the case, you don't have to redraw, you don't have to follow the formula that's given on a formula sheet, okay, which was what? Base squared height over 3. We don't have to do that again. All the work is already done for us. The volume of a pyramid is the volume of my cube divided by a 3. And this is what I mean by understanding the relationship. You don't have to do extra work. And that's what I'm hoping you will do so you can save yourself time. 4,096 centimeters cubed divided by a 3 is 1,365.3 centimeters cubed. Now, how else can I make it tricky? I can go backwards. Once again, if the substitute wants to pause just a little bit so that people can catch up, that'll be fine. Otherwise, this video will be uploaded and you can click the link on Brightspace. Okay, so how else can I make it tricky? A square base pyramid has a volume of 137 centimeters. Determine the volume of a prism with the same base and height. So the same thing. This time, they don't give you the dimensions just in case you were using the dimensions and muscling through by memorizing. The whole point is we don't want you to memorize. If you have a square base pyramid, sorry, if we have a square-based pyramid, something like that, I hope you can see that's 3D, and that has a volume of 137 centimeters cubed, determine the volume of a prism with the same thing. So this time I'm doing it in reverse, aren't I? What if I had a cube that was drawn over, so to make the pyramid perfectly fit inside that cube? What does that tell you? Well, there's no formula we can use because we don't know the dimensions of the pyramid. However, remember that the volume of the pyramid is the volume of the cube or the prism divided by a 3. So in that sense, we can argue algebraically the volume of the prism is going to be 3 times the volume of the pyramid, right? Multiply both sides by 3 algebraically. A division of 3 and a multiplication of 3 turn into just 1. In other words, the answer we're looking for, the V prism, is 3 times 137. That's 411 centimeters cubed. Okay. I'm going to move on because I'm impatient for example 3. I'll finish this off because it's the same stuff but with a cylinder and a cone, and then the rest of class please use diligently trying to complete some of this because this is going to come back, make a cameo appearance on your test coming up. A cylinder has a radius of 8 centimeters and a height of 15. Determine the volume of a cylinder. You may have noticed every question I have, I tend to do a visual because I really like having something to look at. You might as well, so by all means adopt that habit. What is the volume? By formula, the volume is the area of the face, right? The area of the face multiplied by how high it is, which is pi r squared height. 3.14 times 8 times 8 times 15. Approximately 3,014.4 centimeters cubed. Determine the volume of a cone. Remember, the volume of the cone is going to be 1/3 the volume of my cylinder that has the same base and height properties. So 1/3 times 3014.4 is going to be, once again, approximately 1004.8 centimeters cubed. I don't mean to beat a dead horse, but I hope you get it. There is a clear relationship between the two. I am not going to specify if I'm multiplying by 3 or dividing by 3 or multiplying by 1/3 or dividing by 1/3, whatever. But that is the clear relationship. How you get from one to another will depend on your understanding of which volume is smaller and how that translates algebraically. Do your best, everyone. Please don't squander the amount of time you have in class. Make sure you get started on the independent practice. The answer key will be made available to you online. Okay. In the least, if you feel like there's too many questions, I implore you to prepare for the test by doing maybe all the odd questions or all the even questions. Okay? Good luck, and I'll see you tomorrow.